Today we're going to talk permutations and combinations, and as stated in the slide, the permutations is the set of all arrangements of a collection of items where order is going to be important. Now, when we do talk permutations, there's a couple of different notations that are used in different books. One is, as you can see right here, NPR. N stands for the number of total items, and R is the number of items you're going to arrange at a time. And it's also written in other books like this, P with a set of parentheses, N comma R. It says the same thing. The calculation mathematically is you take the total number of items, which is N, and we take the factorial of that, and then we take the number of those, the subset of those items that you're going to arrange, subtract that from the total number of numbers, take the factorial of that, and that's the actual calculation of NPR, and we can use that in our calculator. I'm going to do some of these calculations in an intuitive manner and using this calculation. So let's start with this. How many ways can we arrange 4 different books on a shelf? And I'll start out with an intuitive manner. So intuitively, I have 4 spots on a shelf I'm going to put 4 books in. And I look at my first place and say, well, how many different choices of books do I have to put right here? And I have 4 books in my hand, so I have 4 choices. And now that I've placed a book, I have 3 choices to place a book in this spot on the shelf. 2 choices for the next, and now I have 1 book left in my hand, so that's 1 book. And we can compute this kind of like a counting method, and we end up with 24 total different arrangements. Now, if I wanted to use the NPR concept, I'd say 4P4, or taking 4 items arranged 4 at a time, and I'd use my calculator to grind that out. So let's get to our calculator, and we'll hit 4, and then we will type in the math button, and go over here where it says probability. It says NPR is number 2, so I'm going to hit that, and then I'm going to hit 4 again and ask the calculator to calculate that out, and we end up once again with 24. So now you've seen how to do that on a calculator. Moving forward, so we've got this person, Mary. She's a consultant, and she wants to visit 4 of 6 cities, and we want to know how many ways that she can do this. So the total number, N, in this case, is the 6 cities. The number of different places she's going to visit, or the number of arrangements she's going to have, the subset, is 4. So if we do this intuitively, once again, there's 4 cities she's going to, and she has a choice of 6 cities to go to first. Then she has 3 more cities to visit, as referenced by the 3 open places, and of those, she can go 5 different places. She has 2 more cities to go to, and she has 4 choices, and 1 last city, but she has 3 choices. And there is your quantity. So we're basically looking at 30 and 12, that's 360, right? And then if we wanted to, we could say 6P4, which would also get us 360. So a couple of different ways to do that problem. All right. Moving forward, similar problem. You've got a ski club with 32 members, and you want to know how many ways a person can select a president and a vice president. So you'll notice we have N equaling 32, and the subset is 2 people. So again, intuitively, I've got 2 people from which I get a pool of 32 to pick from. So for president, I have 32 people I could pick, and once I pick that person, now I have 31 choices for my next. Then I multiply those together and get my answer. Likewise, if I wanted to go NPR fashion, I have 32, and I'm taking the number of different arrangements where 2 people are picked at a time. So let's go to our calculator for this one, and we'll go 32, hit our math button, go to that NPR again, hit 2, enter, and we end up with 992, I believe that was. So next, we're going to take a look at a multiple choice type problem. There's a teacher wanting to give a multiple choice test, and in this case, she wants to give each student the same questions, but have each student's questions appear in a different order. And if there's 27 students, what's the least number of questions the quiz could contain? So basically on this problem, we're looking for how many different arrangements we can have of test problems. Now, we just did a problem using the number of arrangements in a book, or that we can place 4 books on a shelf, and we found that if we took 4 different books and arranged all 4 of them differently, we would have a total of 24 different arrangements. Now, assume that you had 4 different questions on a test, and you can arrange them in different manners. You would get a total of 24 different arrangements with those 4 problems. So that's clearly not enough problems to get this problem done. Now, if we took 5 different problems and arranged all 5 of them in different methods, we would end up with 120 different arrangements. So this would be more than enough ways to arrange those 5 problems so that the 27 kids in the class could get different tests. So what we'd want is we'd want a total of 5 problems. So this wasn't just a plug and chug problem. You had to understand what it was asking first, and then actually guess and check a couple of different methods in order, or guess and check a couple of different ways to make the problem up to get your answer. And that's going to be some of the stickiness involved in solving some of these problems. We're going to move from permutations, which talked about arrangements with order, to combinations. And combinations are all the possible arrangements of these items where order is not important. So permutations dealt with order, combination, order doesn't matter. Similar notation, instead of NPR we have NCR or CNR depending on the book you're using. The computation for this is the total number of items over the number of items minus a subset. Factorial, that's the permutation part, and then we're going to divide by also the subset number factorial, which means there'll be fewer combinations than permutations. So here we have a situation where a coach has got to choose 5 starters from a team of 12, and we want to know how many different ways the coach can choose the starter. Now, it doesn't matter about the order in which he picks them here, because we just want to know who are the 5 starters, not the order in which they were picked. So this is a combination problem. Choose is typically a word used in combination problems. So if we wanted to do this problem, we would take 12, C, the subset's 5, because we're choosing 5 guys to start on a basketball team. Again, our calculator will do this problem. So we fire that up. We take the number 12, which is the total number of numbers. Hit math again, go over to probability. There's our NCR, which is 3. Hit 5. And we end up with 792 different ways to choose those starters. Next problem, we've got a conference of 9 schools. We want to know how many interconference games or how many games can be played between 2 teams during the season so that all the teams play exactly once. Now, In this case, we've got a total of 9 teams, so 9 is going to be like our end value, and we're choosing 2. That's our subset number. So we have 9C2. Order doesn't necessarily matter. So popping that into our calculator, we hit 9 C2 and end up with 36 different games on the docket. Whoops, 36. Let's move to our next problem. Done in 2 parts. And you've got 14 juniors, 23 seniors on a service club, and we have to send 4 representatives to a conference. We want to know how many different ways that group of 4 can be selected. Now this problem is not too difficult because we have a total of 14 and 23, which gives us 37 total kids. And we're choosing 4, so R is going to equal 4 in this case. So if we just go 37 C4 and pop that into our calculator, we get, whoops, gotta go back, sorry about that. Let's go 37 again, C4, screwed up again, math, probability, the number 3, 4, gives us a total of 66,045. So let's pop that in. Second problem is much more difficult because in this case it specifies we want to send 2 juniors and 2 seniors. So there's actually 2 different events going on here. Now in order to get this problem done, we have to ensure that we've got 2 juniors and 2 seniors. So if we're ensuring that we have 2 juniors, we have to have choosing juniors as a problem and choosing seniors as a problem, and then treat it like a counting principle. So to choose the juniors, we have a total of 14 of those kids, and from those we're choosing 2. Now combine that with choosing seniors. We've got 23 kids we're looking at, and we're picking 2 of them. This is kind of like a subgroup problem. Now it's a counting principle, so we have this many ways of choosing juniors, this many ways of choosing seniors. We're going to multiply that together to get our final answer. So if we go to the calculator once again, I'm going to go parentheses, 14 choose 2 and multiply that by 23. Choose 2. We get a total of 23,023. And that's our answer here. So the important part of the day is understanding that permutations involves an order and combinations does not involve order. So I'd like you to go ahead and answer these questions. Here are the first 2 you can see clearly. Slide it down so you can get the third one and the fourth one, and there are your last 2. So chew on those for tonight, and we'll see you tomorrow.